This is the third video for More Than Meets the Eye, Transformations of Quadratic Functions, and the topic titled Introduction to Quadratic Functions. This particular video will focus on introducing you to vertex form of a quadratic function and how to rewrite quadratic equations given in standard form or given a graph, and how to rewrite those in vertex and factored form. So let's dig in. We have been studying function transformation form. So I want to introduce this new form for us to then look at how is the new form of quadratic function related to function transformation form. So the paragraph here says that vertex form is the new form I'm introducing you to. And this is in the form f of x equals a times a quantity x minus h squared plus k. Remember, a cannot equal 0 or we don't have a quadratic function. This time the h and the k are important. H is the x-coordinate of the vertex and k is the y-coordinate of the vertex. So I want you to take a look here at the middle of see how the structure of vertex form, how it looks like the structure or how it's similar to the structure of the transformation form. So what I noticed right away is this a value that's being multiplied by the function. Remember, that was vertical dilations and reflections if that was a negative value. That is a lot like the a being multiplied here times x minus h squared. So again, in vertex form, if you think about it transforming the basic function f of x equals x squared and there's an a value, that would also create vertical dilations or of reflection across the x-axis if a was a negative value. Then you'll notice, doesn't look like we have a b value related, but a c value here when we're subtracting that inside the argument or it's happening to the x value. That was our horizontal translations. Remember, it's subtracting c. So if that was like x minus 2, c would be 2. Therefore, it's shift right 2. That was x plus 3. That would be x minus the negative 3. So c would be negative 3, meaning shift left 3. So what that would be here is related to the h value. Again, it's x minus h, so your h value is what is being subtracted. That h becomes the x-coordinate of your vertex, but it does also help relate to horizontal translations. All right, then lastly here, you're gonna see this d value on the end. Remember that was vertical translations, up and down, and that's related to the k value there. Okay, so now with all that information, let's see what we can figure out from the structure of these given quadratic functions that are in vertex form. So I'm gonna rewrite this one to look more like vertex form. And I can tell from this structure, the vertex is at hk. And if you recall, h is and k is here. So therefore, my vertex is at 0, negative 3. The other thing is, I still have an a value. That a value in this function is 2, that's positive. So that also tells me the graph opens upward, meaning that my vertex is actually going to be the minimum, absolute minimum of my parabola for this graph. For this function. So on the next example, we can see h, k. So my vertex is at 4, 9. A is positive 1/2, which means it opens upward. So 4, 9 would be my absolute minimum. And then on the last example here, we can see, be careful with that, plus 2, h, k. So vertex would actually be at negative 2 because we're going to think of this as x minus a negative 2 to create that plus 2. And my k is at negative 5 because that is subtracting 5. So my a value might go, well, where is it? There's this negative sign out front. Remember, that means there's a 1. It's not 0. So a is negative 1. That means it opens downward. And that vertex would actually be a maximum for that parabola. So what can we tell from vertex form that we've learned today compared to the other forms? A still tells us whether it opens up or down, so concave up or down, and HK is my vertex. We can also think, if you really want the axis of symmetry, that would actually go through that x-coordinate of my vertex, so you can think of that as x equals h. So what if I am given a general form of quadratic function and asked to rewrite it in vertex and factored form? So I'm going to need the vertex and the 0. So I'm going to use technology and graph this. And I can see that my vertex is actually at 1.5, 24.5. And I can see that my zeros are at -2, 0, and 5, 0. So I now have everything I need to actually rewrite these in vertex form and factored form. Remember, my A value is -2, my B value is 6, and my C value is 20. So that A value remains consistent across all, across all the forms. So if you recall, down here, that A value remained consistent across general form, factor form, and vertex form. So that means that that A value of -2, I am going to be using that in all of my forms. So if you recall, R of X for vertex form equals -2 times X minus H, so X, and then my H value subtracted from X. That quantity is squared plus my K, which is 24.5. So therefore, I've just rewritten this in vertex form. Next, I'm going to use factored form. If you recall factored form, it was my A value times the quantity X minus root 1. My root 1 is -2, so X minus a -2 is X plus 2 times the quantity X minus root 2, which is 5. And therefore, I've now rewritten that in both vertex form and factored form when I had technology to help me graph. If I don't have technology, then how do I do that? So what I'm going to do is you can pause this video to investigate Dawson and Dave's form, but what they're doing is they're given a graph and they're going to find the important key characteristics. So they're finding their vertex and their x-intercepts, which we've done down here, and they're using those to substitute them into either factored or vertex form and solve for the value A. The key thing is figure out where they substituted those values in. So you can see from where they started, and the second row is where they're inserting values for X and Y in order to solve. And so I am going to do that for an example on the next page, but you can stop and pause and take a minute to investigate this. And when you're ready, then now you can watch me do my example on this page. So moving forward, hopefully you got a chance to investigate. It says write an equation for a quadratic function in vertex form. So it's telling me I already need vertex form. It's telling me that my vertex is at 3, 1. So that immediately I'm thinking HK. And that passes through the point 1, 9. And this is going to be an extra point on my graph, which I'm going to call XY. So if I'm going to use vertex form, I am going to substitute in the information that I know right now. So first, let's just substitute my HK. So that'd be X minus my H plus my K, which is 1. But now I need to substitute in my X and Y values. So 9 equals A times 1 minus 3 squared plus 1. So if I do my algebra, I'm going to get 4A plus 1. Then I would get 8 equals 4A, and I also see that A equals 2. Remember, your A value stays the same, so when I'm going back to my vertex form here, then Y equals 2 times the quantity X minus 3 squared plus 1. And I've now rewritten this in vertex form. All right, now my second example, it says, you need to write the function that has 0, so that's telling me already factored form. So remember, this was at root 1, 0, and this is root 2, 0. And it's going to pass through this point, which will serve as my xy. So I'm going to write this in factored form. I don't know A. I know my first root, which is 6, and my second root is a -4, so subtracting a -4 is +4. I'm going to substitute my X and Y values in. So 8 equals A times 0 minus 6 times 0 plus 4. So 8 equals -24A. And when I divide that, I get A is -1/3. So I'm going to go back to my factored form. -1/3 times X minus 6 times X plus 4. And now we've just rewritten these functions in an equivalent form.